Hello everyone, my name is Najwa Safia Aurelian and I will be guiding you through one of the most important topic in calculus, extending differentiation. Let's begin. Okay, differentiating ax plus b to the power of n. So, given a function in the form of ax plus b to the power of n, we can as the binomial theorem to simplify it. However, we can also as a simpler method using the chain rule, which will produce the sum answer. Okay, differentiating ax plus b to the power of n. So, given a function in the form of ax plus b to the power of n. Student, let's look at this example together. We are asked to find the derivative of the function y equals 3x negative 1 to the power of 2. Now, notice that this is a composition of the function. A power of a linear expression, so apply the change rule here. Let's start step by step. First, break down the exponent. Y prime equals 2 times 3x negative 1 to the power of 2 minus 1. Next, we multiplying by the derivative of the inner function 3x negative 1, which is 3. So, we get y prime equals 2 times 3x negative 1 to the power of 1 times 3. Now, simplify y prime equals 6 times 3x negative 1. And if we expand it, y prime equals 6x negative 2. So, the final answer, y prime equals negative 2 plus 6x. Or y prime equals 6x negative 2. Alright, now we are going to talk about the change rule, but in a more intuitive of informal way. That's why it's called an informal treatment. You can think of the change rule in terms of rates of change. Let's recall a few things. Du over 2 dx is the rate at which dy over 2 dx is the rate at which y changes with respect to x. Dy over 2 du is the rate at which y changes with respect to u. Du over 2 dx is the rate at which u changes with respect to x. So, if y is a function of u and u is a function of x, then we can find the derivative dy over 2 dx by multiplying dy over 2 dx equals dy over 2 du times du over 2 dx. We look at example next to make this clear. Let's this example using the change rule. We are asked to find dy over 2 dx when y equals 2x plus 1 to the power of 3. And answer step 1 in the inner and outer function. Let's u equals 2x plus 1. This is our inner function. Y equals u to the power of 3 This is the outer function. Step 2. Differentiate y with respect to u. dy over 2 du equals 3u to the power of 2. Step 3. Differentiate u with respect to x. du over 2 dx equals 2. Step 4. Apply the change rule. dy over 2 dx equals dy over 2 du times du over 2 dx. Now, substitute what we found. dy over 2 dx equals 3u over 2, 3u to the power of 2 times 2 equals 6u to the power of 2. Step 5. Substitute back u equals 2x plus 1. dy over 2 dx equals 6 times 2x plus 1. So, the derivative of y equals 2x plus 1 to the power of 3 is dy over 2 dx equals 6 times 2x plus 1 to the power of 2. Now, we are going to explore a very practical and important concept in calculus related rates of change. The application of the change rule is very useful for relate rates of change. By applying the change rule, we can obtain a relationship between the quantities of two or more rates of change. If r the radius of balloon, then dr over 2 dt tell us how fast the radius is changing over time. We also know that the volume of the balloon depends on r, and dv over 2 dr tell us how volume change with respect to radius. Now, from these two known quantities, we want to find how fast the volume is changed over time, which is dv over 2 dt. Let's look at the real-life application of the relate rates. We are told that a spherical balloon is being inflated at a constant rate of dv over 2 dt equals 8 cubic meter per second. At the moment, the radius is 4 meters. We are asked to find how fast the radius in screen, which is dr over 2 dt. We also know the formula for the volume of a system. P equals 4 over 2 3 PR cubic. Step-by-step solution. First, as the change rule, dv over 2 dt equals dv over 2 dr times dr over 2 dt. The following formula, dv over 2 dr equals 4 times p times r to the power of 2. Substitute what we know. A equals 4p times 4 to the power of 2 times dr over 2 dt. So, A equals 8 times 64p times dr over 2 dt. Solve for dr over 2 dt. dr over 2 dt equals 8 over 2 64p equals 1 over 2 8p. So the radius is increasing at a rate of 1 over 2 8p meter per second. That's all for today lesson. I hope you enjoy learning about this topic and don't forget to try practice problem. Thank you for your time. Thank you for watching and always keep learning, keep growing. See you.